Thank you, Sally. We couldn't be more excited about this opportunity, and now we feel we got to deliver. We got to make the impact that we're set out to do, and also we need all of your help and much more as we go forward. And thank you also to Anantha and to MIT's other leadership for all your support and advocacy, and to the many members of the community and MIT staff who've worked behind the scenes on all the machinery necessary to get to this day and to help us plan what's next. So next, I'll be joined in conversation with J.B. Straubel, who was a co-founder of Tesla and Tesla's first CTO, and is now the CEO and founder of Redwood Materials, a really exciting, fast-growing company focused on creating a circular economy for batteries. And when we were planning this event, we thought, what is the innovator we could bring who has built manufacturing at scale in the past decade? And JB came to the top of the list. So we really thank you, JB, for joining us and taking the time out of your busy schedule. So please come on up and we can chat.
Thank you.
Thanks, JB. So out in the hallway, we were talking about the connection between technology and manufacturing. And I'd like to start with that. Like, looking back on the companies you've built, how do you see that connection, and what's key?
Well, I think technology is intimately linked to manufacturing. And, the two can't really coexist, or they can't exist without each other. And I do think that's underappreciated, especially in maybe young engineers who maybe see manufacturing as kind of this more vocational, kind of turn the crank, just repeat something. When in reality, the manufacturing, especially of new products and with new methods and integrating new technology to do that, is really innovative. And that is often almost a higher impact on the end product cost or availability or function to the customer than even the design of the product itself. And I had a front row seat to seeing that at Tesla. We spent several years getting the product technology to work and really deep in the weeds innovating and getting batteries to work and prototype electric cars. But we spent 4 or 5 times as long with 10, 20 times more people figuring out how to make thousands, hundreds of thousands of them and make it affordable. That was really what made the impact, was being able to take a new technology and then figure out the way to manufacture it at scale.
Thank you. Hey, can you share some of the choices you had to make in the early days of Tesla?
Well, there were many, many different stories, but we were pioneering both a new technology class, some lithium-ion batteries and some drive inverters and power electronics, a lot of things that hadn't been industrialized yet. So in a lot of cases, we were pulled deeper into vertically integrating than maybe would have been typical. We couldn't just go to a supply chain, because it didn't exist yet. So it forced us to think a lot more deeply about the manufacturability of all the components. If you can go to a catalog and buy something, you sometimes, maybe you take it a little for granted and you're just, I'll order one of these. But almost everything that we designed, we had to go to a very low level, down to the boards and the components on boards, sometimes even to the device level, trying to stand up new supply chains to bring silicon carbide to scale, for instance, in power electronics. I think we were one of the first companies to really do that industrial scale. The innovation benefits are clear. As an engineer, you could sort of see, there's better efficiency, there's better range, better switching, but then to just immediately put that into a product unveiled this whole new range of problems. I mean, you ended up all the way back at not quite the mine, but close to it in some cases, and then solving sequential problems in supply chain, manufacturing, and scalability.
Do you feel that was ultimately an advantage?
It was a huge advantage in hindsight. I think it put an advantage for Tesla in that case. It put the company in a strong position, understanding the fundamentals of that whole linkage, the whole supply chain and vertically integrating there. And a lot of the innovation over the years tended to move upstream too. It was innovation in how you would make the product. That also, I think, is a bit unintuitive. It's to this coupling of technology and manufacturing. But I mean, we would invent, very specialized, sintering machines of how to bond a die to a heat sink and do this, cost efficiently and with low thermal resistance. And that's it's a manufacturing technology. But that would be the forefront of R&D, for a whole host of the engineering team. and it would endure for a lot longer than the first prototype of the product, because they would go into another wave of innovation and engineering, designing the machine that makes the machine. We talked a lot about that, but it was really true. And I found myself pulling our whole engineering team into the factory when many of them didn't expect they'd end up working in a factory or they'd be in a factory, but after they understood the impact and the criticality of that to the mission, as well as to just getting the product to the customers, it really resonated.
Yeah, there's so many exciting problems that may be minute details, but are really, really critical to scale up, and we love to get our students engaged in that here. Could you talk more about how Tesla approached scaling up battery manufacturing? I've read a bit about the Gigafactory, and it seems unbelievable to me the number of batteries made in a day even.
Well, we sort of lived through a very interesting transition and expansion in that ecosystem. The company initially was leveraging consumer electronics, lithium-ion batteries. They were invented in the 2000s, for laptops and cell phones and things like that. And part of our initial idea was, hey, we could take these amazing new devices, this new invention, put it in cars, and suddenly we could go twice as far. That worked. It worked really well. But when we started to scale way beyond the consumer electronics industry, it all sort of needed to be rethought. So with the Model 3 and the Model Y, when we were first launching those products, we did some kind of early napkin math, looking at the volumes. We aspired to make 300,000 cars a year back then of the Model 3, which was more than any other EV had ever made at the time. And that is still small by automotive standards. GM, Ford make millions of cars. But for an EV, that was brand new. And this napkin math we looked at was, well, where would we get that many batteries? And what would it take to expand the supply chain? And we quickly realized that literally just that one car at 300,000 units a year would require the entire world's supply of lithium-ion batteries. And this wasn't that long ago. This wasn't like, eons ago. This was really just 10, 15 years ago. So, that was a big problem. You can't just go out and sort of wave a magic wand and say, I just want to buy twice what the world already makes. So we kind of scratched our heads and said, well, geez, we need to figure out how to solve this. It wasn't as easy as just going to a supplier and saying, could you just build a big factory for us? Because most of them didn't believe us. They'd say, well, that's a nice idea. Great. Call us once you've sold that many cars. But that would be too late. And if we sort of sold that many cars and then went to the supply chain and started to innovate it, you'd have half a decade later. Most people don't want to buy a car and then wait half a decade for you to build a supply chain to give it to them. So we had to basically create a coalition to build a whole new gigafactory. That's what this new term got coined as, to build a much bigger scale of lithium-ion battery factory, something that was bigger than the world had ever seen. And we sort of took this crazy idea at the time to say, we're going to build in the US, again, there was no lithium-ion production at scale in the US, a single factory that would double the world's supply of lithium-ion batteries in the desert in Nevada, too, where there's sagebrush. But that was the bold idea, and it was necessary in order to make that car at scale. There was no other way to do it. There weren't enough batteries. So that was a fun project that I took on. That became my baby, and I sort of moved myself and a Skunk Works team to the desert in Nevada, and we basically started, building this factory, recruiting, companies to join us because we didn't know how to do it, quite frankly. We had a lot of hubris and we're pretty bold and kind of had a vision for what we needed, but we managed to convince Panasonic to come and join us and be the basically co-manufacturing partner for those batteries and cells with us. That was pivotal, and that made it successful. But yeah, that was that journey. That was a lot of fun.
And were there certain ways you approached it to also go fast?
Well, it was, speed was constantly a mandate, really, a necessity. And, I think we tried to strike this balance of, making a lot of decisions in great uncertainty. And manufacturing is often, we were just discussing this, often a discipline that doesn't reward risk very much. It tends to favor, high certainty, then you sort of go and you kind of move R&D far away from it. And we moved all that much closer together. We were engineering the factory while we were building it, literally. And we'd sort of launch a design once we felt like we were 80% in order to go faster, knowing that we would make mistakes. That was the other thing that was kind of hard for people to accept. And I spent a lot of time, in arguing, sometimes heated discussions with, parts of construction and supply chain where they just they weren't familiar with that model. They'd wanted things to be completely 100% baked, and we would come in and say, no, we're 80%, it's probably going to change a bit. We might have to scrap a little bit of work, but that'll be worth it to go fast.
Yeah. And I can imagine the people you hired and the culture of the organization were also key.
It was, the people were what made it possible. I mean, every company is really just a collection of people at the end of the day. And, I think we did a great job of pulling in some of the just world's best and brightest, engineers and leaders and operational leaders, into that endeavor. It was a mission that everyone really deeply cared about. Mm-hmm. It was something most of us just, felt we needed to do, the world needed to do, and it was very close to our heart. And it pulled a lot of, talent and engineering capability that wasn't usually at those phases of the problem. As I said, I was pulling, engineers from Stanford and MIT and a bunch of other universities, out to the middle of the desert to engineer a factory, to engineer a building, to engineer cooling systems and, various production systems that they had not really ever studied or thought about.
And then I'd love to talk more about Tesla, but I think the audience would really enjoy hearing about what you're doing today at Redwood. So tell us about Redwood. How did it get started? What's the mission?
Well, as you said in the beginning, Redwood's mission is broadly to, invent and implement a circular economy, a circular business model for lithium-ion batteries. And, that entails a lot of different pieces of it, but we're focused on recycling of the battery. But it's much more than just recycling. It's a complicated set of reuse and refining and some levels of remanufacturing in different parts of those batteries. And some of this I kind of saw as we were building that first gigafactory. I felt kind of personally almost frustrated in a way at seeing the challenges we were getting from customers on, well, what happens at end of life? I love EVs, they seem great for the environment, but that was a top 5 question I was constantly getting. I didn't feel like we had a great answer for it at Tesla. And the other flip side of that is most people think and fear that it might be a big problem, but it's actually a huge opportunity because a battery is fundamentally different than an internal combustion system. The materials you put inside of that battery stay there. They never leave. So they're nearly infinitely reusable. The nickel, the lithium, the copper, the cobalt, all of these critical minerals that are in the news, it feels like every other day, that we care a lot about, are not destroyed in that application. They're basically a part of the machine that just sits there. It's hermetically sealed. They don't leave. And we have to, extract, mine, build a lot of them to transition our economy toward electrification. But once we do that, we already have the materials. And it seems to me almost an inevitability that if we look into the future, we're eventually going to have a gigantic reprocessing and remanufacturing industry coupled to electrification. That's just physics, whether we do it or someone else. I'm confident that will happen. And I didn't see anybody else doing that. There was no discussion about it. There's no company that was leading it, helping try and define it. But it will be bigger than all the lithium and nickel mining combined. You can also just look at the flow of materials. It will have to be bigger. So I was excited to go and sort of, when it was maybe way too early, arguably, and to start to figure out how could we architect that? How could we invent the technologies and the manufacturing methods, the business methods, to make that work really well and to make it more efficient, both to solve the environmental problem at end of life of batteries, but even more importantly, to close the loop of those materials and reduce the cost of the mined materials. So I'll leave it at that.
So thinking of how many sizes and shapes of batteries there are and how small they are, recycling a battery seems kind of impossible to me. Have you had to invent new technology? Is there a lot of automation? Maybe tell us a bit, if you can, about what's under the hood.
It is highly varied, and there's a temptation to say, I get this from engineers constantly, there's a temptation to say, well, you should just go and tell them to engineer a battery for recyclability. And I say, geez, that would be, in an ideal world, that'd be nice, but we get tens of thousands of different batteries. They're spread over 20 years of history, and Even if somebody started making a perfectly recyclable battery today, we might not see it for 10 years. So we really have to invent and solve a very, very wide problem. All kinds of different, lithium-ion chemistries, iron phosphate, nickel, manganese, cobalt, different variations of nickel, manganese, cobalt, solid-state batteries now, a wide funnel. And that's been a fun technical challenge. It's very technical, trying to come up with the right ways to efficiently and scalably separate these. Because the scale, and this is where I think the manufacturing tie-in is very relevant, we have to engineer for the appropriate scale. Because it's very tempting also to go into a lab and take apart a battery, and you can sort of peel it apart and have very high recovery, and everything can look perfect. And you're like, hey, I've solved it. But then if you go outside and look and you say, geez, there are 20 truckloads of these things showing up every day, and that's accelerating at 50% a year, the sort of take it apart in the lab doesn't work. So that's where we've really invested a lot of engineering time into the scale and matching the scale to solve the end of life that we're seeing today and where it's headed. So we have to create machines that can do this in automated ways where you don't have a lot of human touch. Also machines that can do this with a wide input of different form factors. It could be a battery that's as big as half of a table or a battery that's the size of an AirPod. Both of those are equally relevant, and we have millions or hundreds of thousands of each. So that's been a really interesting challenge, is to invent the technology and then also scale it and then map it into the business world of how do we get these batteries, how do we move them, how do we store and transport them. So we're having a lot of fun.
Cool. I think we have a short video that your team sent us showing some of your factory and operations. If the team can pull that up, please tell us a bit about what we're seeing here.
Well, these are some of the battery modules going into recycling. Those are actually, I believe, a Tesla module. And that whole campus is where we do this recycling. This is what we call hydrometallurgy, where we're doing more of the refining, separating nickel, lithium, and cobalt elements from each other in a almost a chemical refinery type of way. These are sort of some of the products. The products aren't quite as sexy as an EV sports car. They tend to be bags of chemicals and materials, but they're very important. This is showing a little bit of where we're remanufacturing some of those materials into a cathode active material. And this large factory is the scale-up of that cathode active material manufacturing. So we both recover, refine, and recycle, and also remanufacture that cathode material. This is just an office. I think maybe in a second it'll show some of the battery storage, where you can get a sense of the scale of the battery feedstock coming into us. So that yard is all full of batteries. Those are all end-of-life batteries. Waste coming from the entire country. Today we recycle almost 70 to 75% of all the lithium-ion batteries in the country. So there's a vast amount of material that comes in. It's sometimes a little disheartening on one hand to see the amount of waste, but encouraging, I guess, that we can be recovering, harvesting those critical materials from that. And today, thank you. And today, actually, Redwood is the second largest nickel and lithium supplier in the whole country from just recycled materials. There aren't that many operating lithium and nickel mines in the U.S., so we've been able to go very quickly and faster than you can permit new mines to bring online these circular feedstocks. So when we sell materials, we're often selling directly into mined feedstocks. We're sometimes displacing what would have come from a mine or merging our materials back into the same type of supply chain. And over the last year or so, we've really ramped these operations and grown revenue. So the recycling business is now really scaling and ramping, and we are hiring a lot of students. So I'll make a shameless plug here for engineering hiring, but we're constantly looking for phenomenal talent that loves to solve these problems.
I can imagine you have chemical engineers, material engineers, mechanical engineers.
It's a highly multidisciplinary problem, and personally, I love those kind of things. I'm a bit of a generalist sometimes, but I think these systems problems tend to to be just so fascinating because you're again pulling in chemistry and operations and manufacturing and mechanical engineering. They all have to come together kind of in a symphony to be able to design and deliver a project together.
Awesome. Well, congratulations on such progress in such a short time. It's been, what, 5 years or so?
Yeah, about 5 years. So Tesla still feels like my baby. I love the company. I mean, I very much love the mission there. But at Redwood, it's fun to really be helping the whole industry. And part of what we're doing are trying to build tools and solutions, a business ecosystem that can help every OEM, because they all are going to face the same challenges as everybody scales and electrifies, which I think we have to do.
And you alluded to the logistics, which must be fascinating. Tell us about that, and have you had to create new pathways to get batteries to your door?
Yeah, it is an underappreciated problem, and you saw that sort of field of batteries being stored. We have to move all those to us. They didn't grow there. They didn't sort of get mined there. So how to safely handle those logistics, the transport, the packaging of these batteries is a huge effort. A big part of our company is focused on seemingly mundane things, but how do you safely package an end-of-life battery? Because in some cases, they're not in perfect condition. I mean, we're often recycling things that might have been in an accident, they might have been in a fire, they might have been in a flood. So that tends to require almost a level of decommissioning at the front end before we can even package, before we can ship. And all of that has to get solved, otherwise you kind of have a stranded battery somewhere in the world. But that's been a fascinating challenge, and it's pulled us into areas I didn't expect that we would necessarily be working on. But I'm a pretty strong believer in kind of casting a wide net, and we might start an initial vision, but then we don't know quite where to lead, and being open to kind of solving problems that scale that impact.
Yeah, I see a very similar theme of vertical integration between the Tesla example and the Redwood example. Looking at the clock winding down, I think we should take a couple questions from the audience, if that's okay.
That'd be great.
I'd like to prioritize any students who would like to ask JP a question. Please come up to the microphone in the aisle so we can hear you.
Thanks, JB. Can you talk more about the dynamic between increasing flows of energy into large technical systems so that we can increase the circularity of the materials in those systems, so that we can have economic growth without trashing the environment? I'm wearing my hat for you today.
Yeah,
Thanks.
I commend you on your choice of hat. I think I'm an optimist, and I think that over time, we will be shifting to a more and more recycled, ecosystem for those materials that are fueling the energy ecosystem, fueling the battery ecosystem. And today the recycled content is pretty low. It's maybe a few percent. But I am confident that if we stretch this out over decades, that will eventually grow, I think, into the high 90s. There's no technical reason you can't recover and reprocess 95, 98% of these materials. So maybe it seems like science fiction, but if you imagine this world where things are largely electric, they're largely renewable powered, and I think we will have renewable energy powering a reprocessing ecosystem for most of the metals that drive that set of products. So that to me is kind of exciting. You don't need to mine very much, maybe only make up losses from the processing and refining, and the primary energy to do it, I think, can and will be all sustainable.
Do we have another question from the audience? Yeah, please step up to the microphone.
Good morning. Thanks for being here. So a question I had for you was just, as you looked at first EVs and now recycling battery tech, is there any other waste stream that you see coming down the pipe in the future where if you kind of had infinite time to work on a problem, that would be the one that you were targeting next?
Yeah, good question. There are several. Solar panels would put kind of high on my list. E-waste is an interesting one. There's a number of companies in each one of these spaces, and there's some great startups, targeting solar, waste. That solar is a little bit harder because it's, but it has, its own unique challenges. I would probably, spend some time on those if there were infinite hours in the day. But I think overall, any new products, anytime we've sort of, had this technology shift and launched a whole new set of products, it opens up the opportunity to think about the end of life, ecosystem for those products. Some things, where it's been mature for decades, that's all kind of balanced out a little bit better. Lead acid batteries, for instance, that are in, internal combustion cars. People don't think about this, but they're one of the most highly recycled, products in the world, 90+%, because they've been stable as a technology. They've been around for many decades. So I guess I would look at, where, new technology has kind of dislocated industries, or, a new product is ramped very quickly, because those are usually opportunities to think about what comes next where people haven't built it yet.
Thank you.
We'll take one more question.
Thank you very much. Georgie Skipper, research affiliate at MIT and also an Australian, working a lot in this space. It strikes me that you're building an entire kind of new version of an ecosystem, and you're doing that in quite difficult locations, which is somewhat similar to Australia as well. How do you consider kind of attracting the right talent and making everyone kind of share in what you're building? I'm really interested in your approach kind of from a cultural and economic perspective in terms of the ethos in which you approach that.
Yeah, that's a great question. It really is fueled by having, excellent talent and people that, can solve these problems. And sometimes, we are in difficult locations. We're not, always in the best urban environment or don't have all the best amenities. In our factory in Nevada, people were, living in construction trailers and going, we had porta potties for probably 2 years. I mean, it was a little bit adverse at times. But, I think what really, pulls in the best people is the mission. And, having an end goal that really matters, that they can, understand, rally around, and identify with, that sort of transcends maybe some of the, location difficulties or the amenities. I mean, we sometimes are recruiting people from places like Google or Facebook and software companies on our, manufacturing software. And they're coming out of environments, where there were a lot of perks, way more perks than we have, but they're still feeling more, rewarded and energized, and they're just like fired up day to day because they can see, directly the impact, from what we're doing and what their part of that is. So even at Tesla, to me, that was really important in the early days, and I feel like that's just, I think, a really successful formula, for new companies, new enterprises that have a mission, alignment and a key mission that matters. And that's really, the best engineers, the best, people in the world can work anywhere they want. There's, that they're really the commodity talent. And, so companies, I think, really, it's not about pay necessarily. It's about sort of doing something that you really, care about doing that matters at the end of the day. And you have to be really true to that, I think. You can't fake that. Smart people figure that out if you're faking it, and you're like, well, wait, you said this, but then you did that. So I guess I really try and align the whole company and keep us, very consistent with what that mission is and what matters.
I want to close with one or two more. The first is, I can imagine that Redwood is also driving a domestic ecosystem because you're sourcing domestically and then recycling and selling domestically. Could this become global? How do you see that evolving over time?
Yeah, so we have some operations in Germany, actually, already. This is a global problem. And one of the challenges, though, is it's quite hard to move these batteries over very long distances because they are a bit dangerous. I mean, they have high voltage hazards, they have fire risk, they have chemical risks. They're not the most easy, well-behaved thing. So they tend to have more regionalized solutions, at least on a continental level. And that actually, in this moment, sometimes is actually a benefit because once batteries land in a certain region, they tend to stay there. And the raw materials that are with them tend to stay there. So to me, that's also kind of a hidden benefit that we have in terms of regionalizing supply chains, regionalizing manufacturing. Because one thing the US does very well is consume. So we're kind of leveraging, in a way, our consumption to kind of bootstrap the domestic supply chain for some of these critical materials in manufacturing. I think that is going to be a global phenomenon eventually, but it'll probably be replicated in each region. China already does this pretty effectively, but they do it they do it within China. And some of the biggest battery makers in China, CATL, BYD, have quite robust recycling operations. They've been doing it for years, and they've seen it as strategic for years. So, I think we can learn from that.
Thank you. So last, I'd like to ask your advice for our students. Going back to the start of our conversation, technology, manufacturing, also you talked about the systems level picture. What should our students be studying, thinking about, so they can be the most effective future leaders in this transformed economy?
Yeah, it's a tough question, but I would say, try and keep an element of generalism. Thinking about systems. Don't be afraid to sort of understand multiple different disciplines, and I think that can in the real world tend to be quite valuable, where you understand and have a more breadth of understanding in the technical world. I think also really leaning into some of the manufacturing aspects of the world. I mean, it's the topic of today, but go visit factories, go visit mines, go visit supply chain operations, and really sort of get a firsthand understanding of what that's like. Because that you can gain a new appreciation, I think, for what really drives the world and drives some of the ecosystem around the products that we take for granted. Because there are a myriad of interesting technical projects and jobs and roles across all that matter enormously. And I think they will matter more in the future and probably be the ones that can have a bigger impact across these type of disciplines.
Thanks, JB. We'll certainly ask for a load of MIT students to come and visit Redwood in Nevada or South Carolina in the new year.
We'd be happy to host. It's fun to see it firsthand.
All right, thanks
Thank you
again.
so much.